Welcome back, everybody. My name's Mr. Swaner, and today we're going to be talking about slope-intercept form, and we're going to be writing the equation of a line in slope-intercept form from its graph. Before we begin, make sure you pick up your notes so that you can follow along to this presentation. And let's start by talking about what slope-intercept form is. And it's nothing scary, it's just a format that we're going to put our function or our equation into. And that's the form y equals mx plus b. So get used to saying that. You'll be saying that for a long time. And m is our slope, and b is our y-intercept. So this function or this equation is literally in slope-intercept form. And we've talked about slope, but let's talk about what a y-intercept is. And this is probably the easiest part. It's where our graph crosses our y-axis. So it's where our graph would kind of come across. So wherever it crosses there, that is our y-intercept. And that occurs when x is equal to 0. So let's look at this one time and just see why this is actually true. So if I have y equals 1/2 x plus 2, the y-intercept should occur when x equals 0. That's when that graph should cross the y-axis. So I'm going to plug in 0 for x, and I get y equals 1/2 times 0. And 1/2 times 0, or anything times 0, is just nothing. So I get y equals 2. And that is my y-intercept. So let's look at a for real one, and just a quick little brush up on what slope is. Slope is our rise over run, and we're looking for our perfect points where our graph is crossing on the grid lines, not on our coordinate plane, but on our grid lines. And so I see in this instance my slope is 2 over 3. My rise is 2, my run is 3. So that makes my slope 2/3, or 2 over 3. And in y equals mx plus b, that just means that m is 2/3. So now that we have our slope, let's take a look at our y-intercept. And our y-intercept is just where this graph is crossing the coordinate plane at the y-axis. So that is right there. That means that my y-intercept is 2, which means b in my y equals mx plus b is 2. So let's put this all together into y equals mx plus b. I found that my slope was 2/3. So I can write in 2/3 for my slope, or for m. And then I found that my y-intercept is at 2. So I can write that in for b, 2. And then I can just fill in the rest. So I have y equals 2/3 x plus 2. That's the equation of this line here. So let's look at a couple of different examples and see how we do. So again, we're going to be writing these into y equals mx plus b, and I like to always start with my y-intercept. So I count up here, 1, 2, 3. My y-intercept is 3, and now I have half my equation done. This is my favorite part. I'm halfway there. Now the last thing I need to do is find my slope, so I need to find my perfect points where my graph is crossing on the grid lines. And I'll draw in my slope, and it looks, to get from one perfect point to the next perfect point, I need to rise 3 and run 5. That means m, or my slope, is 3 over 5. That's all there is to it. So the slope of this line is 3 over 5. It crosses at 3. The equation is y equals 3 over 5x plus 3. So we're going to start at our y-intercept, and we should see that our y-intercept is just down 2 units from the origin, so that's at -2. I can fill that in. Now I just need to find my slope, so I'm going to draw that in. And it looks like my rise is 2, and my run is 3, which makes my slope and m 2 over 3. Now I'm going to rewrite this because I don't like the tail end of that. I would rather see this written y equals 2/3 x minus 2. I just think that looks a little bit cleaner. So we should immediately see here that we have a negative graph. So our slope is going to be negative. But we're going to start at our y-intercept. So let's count up here. We've got 1, 2, 3, 4, 5. So our y-intercept is at positive 5. And then my slope, remember this is negative. So I've got a negative rise. That's a negative 1. And my run is 3. So my slope is negative 1/3 x plus 5. Next line, we're going to look for our y-intercept, and it looks like my y-intercept here is negative 2, so I'm going to write in negative 2. And then now I need to find my slope. Again, we should notice that this is a negative graph, so my slope is going to be negative. And it looks like that my slope is negative 2 over 3. So I'm going to write in my slope as negative 2 over 3. And again, I'm going to rewrite the end of this just to make it look a little bit nicer. Here we have a very steep negative graph. And when I'm looking for my y-intercept, it appears that the graph crosses at 0. So I could say that my y-intercept is plus 0. But I'm going to go ahead and leave that off at the end. But for now, I'm going to move on to my slope and find my perfect points. Remember, this is a negative graph, so my slope is going to be negative. And it looks like that I go down 2, so negative 2 over 1. My slope is negative 2 over 1. And this can be simplified a little bit further. Negative 2 over 1 can just simplify to negative 2. So I'm going to write the entire equation as y equals negative 2x. In this equation, like always, we're going to begin by looking at the y-intercept. So I count up 3. My y-intercept is 3. And then in looking for my slope, there is absolutely no rise, and it runs for infinity. So I have a slope of 0 and a y-intercept of 3. And I'm going to rewrite this because there's no reason to keep that 0x in there. I'm going to rewrite this as just y equals 3 because y equals 3 for any x, but there are 0x in this situation. My last graph is an undefined graph, and just like I wrote in my last graph that y equals 3, this is going to be very similar, although this is undefined again. This is just x equals 2, because x equals 2 for anything that y is. There's no y in the equation. X just equals 2 for everything. So in closing, slope-intercept form. What is it? It is written in the form y equals mx plus b. And in this form, m is what? M is the slope, and b is the, I hope you said, intercept, the y-intercept. Thank you very much for joining me. My name is Mr. Swaner. And until next time, study hard and keep practicing.